Here in example 3, we're going to graph a polynomial function. Now, for problems like this, they can get kind of involved, kind of complicated if you don't have the chart already written out, which you might not. I'm going to try and keep this as straightforward and simple as possible so we can just get a general understanding of what we can interpret and how we can use a chart to help us draw a sketch of the graph. And I really, really want to stress this is a sketch of the graph. The chart is not always going to tell us exactly everything we need. It's just going to give us an idea of what this graph would look like. So let's go to this. Consider the polynomial function f of x equals negative 0.5 x to the fourth plus 3x squared plus 2. So one of the first things I'm going to notice or note to myself is that I have an even degree. So this is going to be an even degree. And I notice that I have a negative leading coefficient. All right, and what that tells me is that is similar to negative x squared, which would be a parabola kind of reflected. So that tells me my end behavior is going to be down, down. All right, so that's a good thing to keep in mind. So when I'm drawing my graph, I know what the end behavior should look like heading towards positive and negative infinity. So make a table of values and identify the intervals where the function is increasing or decreasing. I've already written out those for myself. You would use a graphing calculator. You could use an online program like Desmos and then kind of click at certain points along the graph. But finding the table in a graphing calculator is probably your best option. So make a table of values, we did that, and identify the intervals where the function is increasing or decreasing. For that, we're looking at the y values. So from 11.5 to 6, all right, this is increasing. The numbers are getting larger, all right? 6 is larger than negative 11.5. Then from 6 to 4.5 to 2, this is decreasing, all right? The number is getting smaller. From 2 to 4.5 to 6, this is now increasing again. And then here we are decreasing. What that's going to wind up telling me is about turning points in my graph. So now I'm actually going to draw a quick sketch of those plots, those points. So negative 3, negative 11.5 is going to be somewhere way down here. Negative 2, 6, that'll be up here. What if negative 1, 4.5, so 1, 2, 3, 4, somewhere in here. 0, 2, 1, 4.5, so that'll be a mirrored version of that. 2, 6, another mirrored version. This is not drawn very accurately. Remember, this is by hand. And then we have some point way down here. Okay, so remember, our end behavior is going to be down, down. That's important. I know that at some point it's increasing and it's decreasing, increasing, decreasing. So I'm going to try and connect these dots as best I can. And it's important, again, I'll stress this, is that this is a sketch. So let's start here. We know from negative 11.5 to 6, it's going to be increasing, so this should be going up. And then when we get there, it's going to start, well, I did not want to do that. It's going to change directions and it's going to start heading down. So this is going to go up, and then it's going to kind of loop back down, and then change up again, and then loop back down. And my end behavior is down, down. So that matches up, that's good. Now, here's a couple things I want to point out. I have no idea if this turns exactly right here like this. Okay. This graph may continue to go up like this and then turn down this way. All right, it's possible. We don't know that exactly because we just have this table of values. We don't have all of the points. So we know that there's going to be a turning point somewhere around here. Somewhere around here. We just don't know exactly where it is. So that's why, again, I wanted to stress that this is a sketch of this graph. All right, and that's pretty much all we're looking to do here. All right, so we use that table of values. We identified some key features. We know that it's going down, down. We know that here and here there are turning points. Again, I don't know if that's exactly where it is, but there's a turning point at each of these places. And I also have a turning point right here. One of the things that I want to point out, and you'll see over time, our highest degree was 4. What that tells me is I'm going to have a maximum of 3 turning points. I might not have 3, but I can't have more than 3. And that's shown here. I have 3 turning points, which makes sense. It's kind of mathematically correct because my highest degree was 4. So that tells me I can have 3 turning points. If my graph had 4 turning points, something would have been wrong. Right? Something would clearly be wrong. You can't have as many turning points as that degree. That's really all I wanted to point out. You could figure out x and y intercepts from here. Again, we didn't really need the graph to determine end behavior, but it does help to kind of verify that. So let's run with that. Now, that was part A. Let's take a look at part B. How can you use the graph to estimate the average rate of change over the interval -2, 0? So we're looking at the interval from here to here. All right, so these are the 2 points we want. We want to use the point -2, 6. So we have the point -2, 6 and 0, 2. I'm going to draw a really poor sketch of this graph. It looked something like this. They're looking for the average rate of change between here and here. All right, they want to know what this average rate of change was. Now, we don't know exactly what the slope of that portion is. So this, change colors here. We don't know exactly what the slope is of this piece here, but we can figure out the average rate of change. And to do that, we're just going to use our slope formula. So we want to do, that's not the marker I want. We're going to do y2 minus y1 over x2 minus x1. So that would be 6 minus 2 or 2 minus 6. But if I go 6 minus 2 this way, I need to do -2 minus 0. So -2 minus 0. 6 minus 2 would be 4. -2 minus 0 is -2. And this would be -2. Remember, your average rate of change is slope. -2 makes sense. It was decreasing. Go back to that highlighted part. My slope was decreasing, so it should be negative. So always verify that, check that your answer makes sense. So let's write that out. I did it again. The average rate of change, we'll say the whole phrase, over the interval -2, 0 is -2. And there you go.